Hello everyone. Hello everyone. Good afternoon. How was your test today? So today we are going to talk about our test discussion. Okay. Everyone can see the screen. Okay. And they can audible and my screen is visible. Yes. Thank you for responding. Yes. Thank you. Okay. So how was your paper? How was your paper? Yeah. Okay. So now let's start with our today's discussion. Okay. But the first question is very, very simple. Okay. What is the formula for minimum molecular mass? Okay, let's make it big. Okay, yeah. So you can see the screen and I've shared the screen. You can see that. Okay. So compound contains 3.2% of sulfur. What is its minimum molecular mass? So here we need to calculate the minimum molecular mass for a given sulfur compound. Okay. So ABCD, what was the answer? Yes. Minimum molecular mass. Molecular mass is equal to, what is the formula for minimum molecular mass? Yeah. Atomic mass. Yes, atomic mass divided by percent of the element present. Okay, into 100. So how much is the atomic mass of a given element? Atomic mass of sulfur is how much? 32. And how many percentage are given? 3.2. Right? And that's why the answer will be 10 into 100. It is what? 1000. Right? Yeah. But in answer key, the answer given is 500. Right? That was the discussion about. So here what we have to do is we have to take 6.4% of sulfur. Okay. So if we take 6.4% of sulfur, our answer will be what? 500. So just rearrange this equation. 32 divided by 6.4 into 100. Here what will be the answer? Yes. Here it will be what? 1/2 into 100. Okay. 1/2 into 100. And that's why it will be what? Right? What will be the calculation of this? 32 upon 6.4. 32 upon 6.4. It will be what? 5. It will be equal to 5 into 100. So the answer will be 500. Okay. So answer was D given in the answer key. Okay. So take the value here. Compound contains 6.4% of sulfur. Is that clear to everyone? Yes. Is that clear to everyone? A compound contains 6.4% of sulfur. What its minimum molecular weight? So in this way, you have to calculate that. Please remember this formula. Minimum molecular weight or mass is equal to atomic mass divided by percent, whatever percentage are given, multiply by 100. Okay. Everything is clear? Next question. In iron atom, how many electrons are there in N is equal to 3 and N is equal to 2? So iron atom, what is the atomic number? 26. You know the electronic configuration 1s2, 2s2. Should I write the electronic configuration? 1s2, 2s2, right? 2p6, 3s2, 3p6. These are what? 10. Then 3p6, 8 ho gaya. Then what is the 3d? 6 and 4s2. Right? So how many? 26. Okay, हो गए 26 हमारे. Yes, 26. So outer electronic configuration is what? 3d6, 4s2. ये क्या हो गया हमारा? The noble gas. Okay, that will be our noble gas. So we have asked to determine how many electrons are there in n is equal to 3 and n is equal to 2. So n is equal to 3 means what? When the principal quantum number is 3 and the azimuthal quantum number is 2, which orbital is there? So 3 is what the name of the orbital, and 2 is what? When n is equal to 0, it is s orbital, it is 1, it is p orbital, when 2, it is d orbital. So 3d orbital, how many electrons are present in 3d orbital? See here, you can see in 3d orbital 6 electrons are present. So our answer will be C. Any doubt? Yes, any doubt? Everyone? Everything is clear? Okay, good. Next. Let's move on to the next question. Equilibrium constant K1 and K2 for the following equilibrium is. So here we have given two reactions. This is reaction number 1 and this is reaction number 2. And we have asked that how these equilibrium constants are related to each other. So first of all, let's calculate the equilibrium constant for first reaction, that is K1. What is the equilibrium constant? Yes, product divided by reactant. Concentration of product divided by concentration of reactant will give us what? Equilibrium constant. Okay, and whatever the number of moles are present here, they will go to the power of this. Right? What is K2 given? K2, how you will draw the K2 here? How you will write the K2 here? So simply, I'm just writing that product divided by reactant. Product NO square divided by reactant is what? NO2 square. And here O2 is also there into the numerator. Okay, product divided by reactant. What is our formula? Equilibrium constant. Equilibrium constant is equal to product divided by reactant, concentration of product divided by reactant, and whatever will be the number of moles present before that given quantity, you have to write that into the power. Okay, now we need to find out what is the relationship between K1 and K2. Okay, we need to find out what is the relationship between K1 and K2. So what you will do, see here, NO2, NOO2. Okay, this is K1 and this is K2. So everything is K2. Okay, first of all, K2 is given in our problems. So what I will do is, therefore, K2 is equal to. Therefore, K2 is equal to. So for K2, what I will do is K2, NO2 square, O2 and NO2 raised to 2. Right? This is NO2. This is NO2 below. This is into numerator. This is into denominator. This is into denominator, NO and O2 raised to half, and this is into numerator. So you can easily see that K2 is inverse of K1. Okay, K2 is inverse of K1. So if I do the inverse of K1, now what you will get? NO2 will be here. Okay, NO2 will be here. And divide wale term will go to the numerator. Okay, what are the divide term? NO concentration and O2 raised to half. But what is this? Here 2 is present, here half is not present, and here 2 is present. So K2 is nothing but what? 1 of K1 square. 1 upon K1 square. K1 ka square agar hum logon ne kiya, we will get 2 here, and multiply by 2 means 1 you will get. So what is the answer? K2 is equal to 1 upon K1 square. Any doubt? Yes? You are understanding this? Very simple calculations. Right? Next reaction. So in this next reaction, what is given? Next problem, what is given to us is we need to find out the precipitate of Ag2CrO4 is obtained when equal volume of followings are mixed. So when precipitate will obtain? When the ionic product is greater than the solubility product, then and then only we will get the precipitate. So here in the reaction, what is there? Ag2CrO4. When it will dissolve, what will happen? We will get 2Ag plus, right? And CrO4 2 minus. These are present in the solution. Okay, so in order to occur the precipitation, here what is given, equal volumes are mixed. Equal volumes are mixed. So this is solubility. Its solubility we will write this way, 2s, and its solubility we will write this way. But here equal volumes are given. So that's why one volume of Ag and another volume of Cr4. So that's why it becomes total volume 2V. V plus B, it becomes total volume 2V. So here we are going to divide the given concentration. This is what our concentration. We are going to divide the concentration by 1 by 2. Whatever the concentration is given to us, we are going to divide it by 1 by 2, and we will determine the solubility product of that as well as ionic product of that, because solubility product is given. If the ionic product is greater than the solubility product, then and then only there will be the precipitation takes place for all the four. So for all the four reactions, we need to find out, for all the four options, we need to find out the ionic product. So first of all, let's start for the first one, that is A. Okay, let's start for the first option, that is A. So for A, what is given is, yes, ionic product we have to determine. What is the formula for ionic product? Ionic product is equal to Ag plus its square into CrO4 2 minus its concentration. Okay, its concentration square and multiply by this concentration. Okay, and right now I have told you concentration, whatever concentration you are going to take, divided by 2. Okay, so for A, 10 raised to minus 4 divided by 2 bracket square into 10 raised to minus 4 divided by 2. Okay, so when you will do this calculation, you will find out that what will be the answer, multiplication, what will be the answer. Okay, you just do this calculation. What you will get is, you will get your answer 10 raised to minus 4 square. 4 square is equal to 16. 16 minus 4, how much? 10 raised to minus 12. Okay, for A. For B, what will be the answer? For B, 10 raised to minus 2 square. Okay, for B, 10 raised to minus 2 square into 10 raised to minus 3. 10 raised to minus 2 square into 10 raised to minus 3. Okay, so what will be the answer here? Yes, calculate karo, write down, calculate it. 10 raised to minus 2 by 2 and 10 raised to minus 3 by 2. So 2 2s are 4, 4 plus 3, right? 4 plus 3, 10 raised to minus 7 divided by 4, right? For C, it is what? 10 raised to minus 5 square. 10 raised to minus 5, yes, square divided by 2, here divided by 2. So 5 square are what? 25 minus 3. How much will be? 22. So here 10 raised to minus 22 by 2. So as the minus power is going to increase, that value is lesser as compared to 10 raised to minus 8. So if we want ionic product to be more than 10 raised to minus 8, then it should be value lesser than this. Minus 8 से कम होनी चाहिए value. तो कहाँ पे हम लोगों को कम मिली value? यहाँ पे. So the option is option B. Okay, we should get minus में जो power का value होगा, that value we should get less. 10 raised to minus 7, 10 raised to minus 6, 10 raised to minus 5, then and then only our ionic product will be greater than the solubility product, and that will be our answer. Here when you solve 10 raised to minus 2 into 2, that is 10 raised to minus 4 and minus 5. So you know that 10 raised to minus 4 multiply by 10 raised to minus 5. When base are same, what will happen? इनका क्या होगा? They will get undergo into addition. So 4 plus 5, it will be 9. So यहाँ पे 10 raised to minus 9 आ रहा है. And that is not lesser, right? That is not bigger than 10 raised to minus 8. It is actually lesser. So that's why our answer will be B. Any doubt? Yes. Next, consider the reaction at 300 Kelvin. Okay, here we have given a reaction and we need to calculate the delta U for combustion of 1.5 mole of benzene. Okay, so here 1 mole of benzene reaction is given and we need, and for that delta H is given. And now we need to calculate delta U for 1.5. So first of all, let's calculate delta U for 1 mole. And from that we will get the value for 1.5 mole. So you know the formula, delta H is equal to delta U plus delta Ng RT. Okay, here delta Ng is how much? See here, this is gas. Okay, this is liquid, so don't worry, this is gas. Okay, so what you will get, delta Ng will be equal to here, delta Ng is equal to number of moles into the product minus number of moles into the reactant. Okay, when you will do this calculation, you will get 6 minus 15 by 2. Yes, the answer will be yes. Yeah, product 6 minus 15 by 2. 15 by 2 means what? 7.5. So you will get how many number of moles? 1.5. Even though it is minus, or you can do that reactant minus product kar do. Okay, reactant में 15 by 2 minus 6 and this is 7.5 minus 6. You will get 1.5 as the delta Ng. So delta U you have given into the, sorry, delta H you have given minus 3271 kilojoule. Delta U you can calculate. Delta Ng you have calculated just now. Put 8.314 value for our R, and T, it is given that the temperature is 300 Kelvin. So already in Kelvin answer is given. So just do this math, simple maths, and you will get delta U value. It is equal to minus 3267.25 kilojoule. Just calculate this, okay? Since you got this value for 1 mole, what will be the value for 1.5 mole? Just multiply this by 1.5. You will get delta U for 1.5 mole. Okay, and that is equal to 4900.88. That is, you will get the answer B. Okay, 4900.88 kilojoule. Okay, just do the calculations. Okay, you can do that. Yes. Will you please reply me? Okay, you can do this calculation, right? Now let's solve the next question, that is 51. Strongest reductant is. So here reducing power is inversely related to oxidation state of a given central metal atom. Okay, so reducing power is inversely related to oxidation state. So whatever is the compound here, reductants are present. Those which will have the less oxidation state, they will have the greater reducing property, that is they will be strong reductant. Okay, so let's calculate the oxidation state now. So P2O64 minus. So we don't know the oxidation state of phosphorus. So I will write 2x. X is what? I don't know the answer. That's why I'm writing X. Okay, 6 are the oxygen, and you know the oxidation state for oxygen is minus 2. Okay, and this is equal to minus 4. Okay, this will be equal to minus 4. Now, next, what will happen here? 2x plus 6 into 2, it is minus 12. It will be equal to minus 4. So, 2x is equal to minus 4 plus 12. Do the calculations. You will get here 8. X is equal to what? Plus 4. So, you are getting here value of x as 4. Okay, this is our oxidation state. Next, for B molecule, H3PO4. So for H3PO4, what will happen? So for hydrogen, you know the oxidation state is plus 1. So 3 molecules are there, so 3. For P, I don't know. For oxygen, it is minus 2. So it will be minus 8. Okay, it is equal to 0. It is a neutral molecule, right? Next, X is equal to how much? You will get X is equal to plus 5, right? Next molecule, that is H2PO2 minus. So here for hydrogen plus 2, for phosphorus, I don't know. For oxygen, minus 2 into 2, minus 4. And overall molecule has minus charge. That's why it will be like this way. So X plus X minus 2 equal to minus 1. So X is equal to minus 1 plus 2. So X is equal to plus 1. So this is having plus 1 oxidation state. And our reducing power for relation is what? Oxidation state should be small. So this is small, right? Here plus 5, here plus 4. We are getting here plus 1. So let's try for last one, and then we will finally find the answer. P2O74 minus. So here 2P means we don't know the P oxidation state. Okay. And for oxygen, it is minus 2 into 7. That is minus 14 is equal to minus 4. So 2x is equal to minus 4 plus 10. So it is what? 2x is equal to plus 6, that is x is equal to 6 by 2, that is 3. Yes? Everyone? No. Something here, 14 will be there, right? 14 minus 4, it will be 10. and 10 by 2, it will be 5 plus 5. So this is plus 5, this is plus 5, this is plus 4. Which is the lesser value? This one. So option C will be our correct answer. Right? Any doubt? Are you getting this? This is not getting faster for you, right? For hydrogen, oxidation state, take plus 1. For oxygen, oxidation state, take minus 2. Okay? Okay. Now, next question. What is the density of, yes, what is the density of SO2 gas at STP? So, we need to find out here density. So, you know the formula for density. Density is equal to mass upon volume. Right? Density is equal to what? Mass upon volume. So here, what is the mass? What is the mass? Or you can say that molecular weight. Okay, molecular weight of given molecule. So what is your molecule? What is your molecular weight of SO2? Sulfur is 32, oxygen 32. Sulfur atomic weight is 32, oxygen is O2 is 16, 16, 32. So total is 64. Divided by for volume, here we have to take volume as 22.4. Okay, just do this calculation. You will get the answer. It is nearly equal to 3 grams. Okay, density we have to find out. So that's why your answer will be A. Next, how many tetrahedral voids are occupied in diamond? So this is a theoretical question. It is a fact. So around 50, half, okay, 1/2 of voids are, 1/2 of tetrahedral voids are present in a diamond. That is 50% of tetrahedral voids are present here. Next, which of the following is not correct match? So here emulsion, from the emulsion concept, the question has been asked. So here what is happening? So emulsion, okay. Okay, this is for next question. 54 question, emulsion. Okay, so what is emulsion? Emulsion are liquid-liquid colloidal system. It is what? Liquid-liquid colloidal system. So here it is a mixture of two immiscible or partially miscible liquids. Okay, when they are shaken together, what you are going to observe? Dispersion of one liquid and other is obtained, then it is known as the emulsion. Okay, what is emulsion? It is a mixture of two immiscible liquids, okay, or partially miscible liquids. When they are shaken together, a dispersion of one liquid in other is obtained, which is known as a emulsion. So generally there are two types of emulsion: oil in water, okay, and another one is water in oil. Oil in water and water in oil. So when we talk about oil in water, the examples are vanishing cream, milk, etc. Here, what is the example? Vanishing cream and milk are the example. They are oil in water. And when you talk about water in oil, the examples are cream, butter. Okay, you must have been studied this. Okay, so cream and butter. So here, which is not correct? So which is not correct here? See, butter is water in oil. Butter is water, oil in water diya hai. So this is not correct. Okay, and that is our option. Vanishing cream is what? Oil in water. Correct hai. Cold cream is what? Cream मैंने बोला आपको, water in oil. This is also correct. So the correct answer is, which is not correct. Okay, butter is what? Butter is water in oil. Next, next reaction. Okay, next problem 55. 2A gives B plus C. 2A gives B plus C. It would be a zero order reaction. If see here, reaction is given to us. The rate of a given reaction is directly proportional to what? Concentration of that given reactant. So if we want our reaction rate to be zero, so what is the one thing we should keep constant? So if the concentration is constant or it remains the same, then what will happen? The rate will definitely become zero. So let's see which option is there. Rate of reaction is proportional to the square. That is not happening. The rate of reaction remains same at concentration of A. This is correct. The rate remains unchanged at any concentration of B and C. That is also not required. The rate of reaction doubles if the concentration of B is increased to double. So this is also not correct. So rate when independent of reactant, then only the independent of reaction concentration, reactant concentration, then only we can say that the reaction will be zero order reaction. Okay, any doubt? Okay, next question, 56. Okay, 56. Which of the following has maximum conductance in aqueous solution? So we need maximum conductance. So when we talk about the conductance, now we mostly talk about the size of the ions present. Size of ion. If the size of ion is small, it has highest speed. Okay, it has highest speed in a solution, and since it has a highest speed, it shows maximum conductance. It shows maximum conductance. So which of the following is smallest in size? Li plus is what? Smallest in size. Okay, maximum conductance in aqueous solution. Okay, so our answer will be Li plus, right? Any doubt? Next, 0.01 molar solution of this complex in water shows freezing point depression. If K for water is 1.80, the correct formation of above compound is. So we need to find out here what is the value. Okay, so what will be the value? Let's calculate that. Okay. Okay, here, sorry. Yeah. Okay, so here I have explained wrong. Sorry. Okay. Since it is having the smallest speed, smallest size in lithium is having smallest size, what will happen here, that most of the solution or water molecule will surround this molecule, and that's why its size will become more. Its effective size will be more. Actually, lithium is smaller in size, but due to its smaller size, it will combine with the surrounding molecules, and that's why its effective size will be more. Okay, its effective size will be more, and that's why it will slow down its speed. Okay, but since cesium plus is already bigger in size, there will be lesser amount of ions present inside the solution, and that's why it will have the lesser resistance of ions in the solution, and so it will have the maximum conductance in aqueous solution. ठीक है, lithium plus क्या है, छोटा है, सोल्यूशन में आप डाल दो उसको, क्या हो जाएगा, बहुत सारे आयंस ऑलरेडी सोल्यूशन में प्रेजेंट है. ठीक है, अदर आयंस आर प्रेजेंट इन द सोल्यूशन. सो व्हाट विल हैपन, लिथियम स्मॉलर इन साइज, it will have more resistance to move as compared to cesium because it is bigger in size, so it can move into the solution with the maximum conductance. Okay, any doubt? Yes, next one. So here we have given that pt, nh3, 4 and Cl4. Okay, I will write pt, nh3, 4, Cl4. So this is our complex. Okay, and we have asked to determine the freezing point depression is given to us, that is delta T, right? Delta T is given 0.0054 degrees Celsius. Okay, then we have given Kf also. Kf is equal to 1.80 degrees Celsius. Okay, and what we have given is the correct formulation of above compound is, we have given the concentration. Okay, so the formula for this is what, delta T is equal to, yes, delta T is equal to Kf into molality, right, into 1 minus alpha plus n alpha. Okay, 1 minus alpha plus n alpha. So here gives n moles of ions on complete ionization. So this molecule gives n number of ions after complete ionization, and that's why here A becomes equal to 1. A becomes equal to 1. So I will put all the values. Delta T is what? 0.0054. Kf value is 1.80. Okay. Multiply by molality value is given 0.001. Okay. 0.001. Multiply by here. What will be the answer? Here n will be the answer. Okay. 1 minus alpha plus n alpha. Here only n is remaining, and you know that how many moles are given by this molecule. So it will give 3 moles. N is equal to 3. How it will give 3 moles? So I will show you the formula. Okay. ओके यहाँ से आपको n का वैल्यू मिल जाएगा, n will be equal to 3. Okay, this is n. Alpha will get cancel out. Okay, 1 minus alpha plus n alpha. Okay, alpha value or a value, you can say that it is 1. Okay, here alpha is equal to 1. That's why n will be equal to 3. ये calculation करो, आपको n की value मिल जाएगी. N is equal to 3. So since n is equal to 3, that is number of moles of ions getting completely ionized are 3. So which will be the correct formula? 1, 2, 3, and 4. So which will give us 3 ions? See here. So our option 2, what is there? 2 chlorine will get dissolved into the solution and 1 our complex ion. So overall ions will be what? 3. Here overall ions will be what? Only whether this will get undergoes into ionization. Here 3 plus 1, 4. Here 1 plus 1, 2. Okay, here only 1. Okay, only 1. So that's why our correct answer will be option B. Is that correct? Any doubt? Next, which of the following is monomer of Teflon? So this is a direct answer. Teflon का monomer कौन सा है? ये होता है, ठीक है. Phenol and benzoic acid can be distinguished by NHCO3, neutral FeCl3, Br2 plus water, A and B. So in practical, you must have done this reaction. We use neutral FeCl3 as well as NaHCO3. So A and B both are correct. Next, RCONH2, Br plus KOH and LiLH4, A और B हम लोगों को जो मिल रहे हैं product, they are position isomer, they are homologous, or they are functional isomer. So when Br2 KOH reaction is occur with the amide, that reaction is known as Hofmann bromamide. Reaction is known as Hofmann bromamide. Okay, because there is a formation of that. Okay, so here what will be the happen? There will be production of RNH2. Second reaction, LiLH4 when react with the amide, there will be formation of RCH2 NH2. CO group undergoes into reduction and it gets converted into CH2 with the help of very strong reducing agent. LiLH4 is very strong reducing agent. It converts CO into CH2. Okay, so see, this is our A molecule and this is our B molecule. These are position isomer, these are functional isomer, they are homologous or they are identical. So this is amine, this is again amine. It is having RNH2, it is having one extra CH2. So that's why they are what? Homologous. They are from the same type of compound. That's why they are homologous. So our answer will be answer option B. Next, which of the following structure will give a positive test with Tollens reagent? So in order to occur the Tollens test, what should be present in our given compound? Yes. See here, keto group is present. Here alcohol group is present as well as aromatic ring is present. Here what is there? Anhydride group is present. Right? Here what is present? Ester, sorry, here ester. Ester is present. Here what is present? Aldehydic group. So aldehydic group can be gives positive test with the Tollens reagent. So our answer will be C. Next, 62. Concentrated KOH के साथ reaction होगा. So what you are going to get? So when you the reaction takes place na pH CHO. This is which type of reaction? Canizarose. Okay, which is not having a alpha hydrogen compound, which is not having alpha hydrogen. So pH CHO reacts with HCHO. Formaldehyde reacts with benzaldehyde. There is a production of, okay, more relative towards nucleophilic aromatic, nucleophilic addition reaction. So here, this molecule is more reactive for nucleophilic addition reaction. Okay, and it undergoes into oxidation. So here there is a formation of pH CH2OH. Okay, and plus oxidation, it undergoes into nucleophilic addition reaction and it forms the compound like this way. So what is our correct answer? Answer A. Okay, Canizarose reaction. Any doubt? Yes, any doubt? Next question. So which is the major product of the following reaction? So here electrophilic substitution reaction, right? So what is happening here? Br2 FeBr3. Okay, bromination हो रहा है. For bromination, we need to find out here which will be the activating species, OH or CH3. So you know that OH will be more reactive here as compared to CH3. So with respect to OH, the incoming nucleophile is going to, the incoming electrophile is going to attach to the given phenol. Okay, this molecule, given molecule. So with respect to OH, what will be our product? ABCD. OH is more activating than CH3. Okay, and that's why electrophile Br plus will attack according to OH. So according to OH, this is what meta. So that is not good. This is not going to happen. This is also not going to happen. So this is correct answer with respect to OH. That is ortho to OH. This will be the correct answer. Next, the heating of phenyl methyl ether with HI produces ethyl iodide, phenol, iodobenzene, and benzene. What will be the correct answer for this? Very simple. Yes, phenyl methyl ether. Ether को reaction करो HI से, what you will get? Yeah, someone has responded. Phenol. Okay. Next, reactivity order for SN1 reaction is, next reaction, very simple. SN1 reaction के लिए we need to find out the reactivity order. So what will be the correct order here? ABCD, ABCD. Yes, SN1 reaction. So reactivity towards SN1 is directly proportional to stability of carbocation. Stability of carbocation, right? For SN1. So which carbocation is more stable here? C. Yes, if this goes, here will be the positive charge. This goes, here will be the positive charge. Here will be the positive charge, and here will be the positive charge. So when you see this molecule, what you can see here? Here it is having 1 alpha hydrogen. It is having 2 alpha hydrogen. It is having 3 alpha hydrogen. 3 alpha hydrogen, 2 alpha hydrogen, 1 alpha hydrogen. And this is 0 alpha hydrogen. Okay. So as an alpha hydrogen are maximum, okay, the stability to given carbocation is maximum. Why? By using the hyperconjugation effect. Okay, by hyperconjugation effect, we can stabilize this positive charge present on the given methyl group. Okay, so B are having 3 alpha hydrogen. That's why it is more stabilized as compared to C, as compared to D, and as compared to A. So what is our correct answer? D. B over C over D over A. Are you getting it? Stability of carbocation पे depend करता है reactivity of SN1, and how we can stabilize the given carbocation by having the more alpha hydrogen to it. So here 3 alpha hydrogen, here 2 alpha hydrogen, here 1 alpha hydrogen, here 0 alpha hydrogen. That's why the reactivity order will be this way. Okay, any doubt? Okay, very good. Next, which of the following does not give test of unsaturation with Br2 in CCl4? Yes, tell me. Which of the following will not give taste of unsaturation with Br2 in CCl4? A, B, C, D. Yes. Next, 67 is also easy. Easy questions. These two are very easy questions. Yes. Yeah. So alkene gives taste with unsaturation with Br2 in CCl4. Alkyne also gives taste with unsaturation of Br2 in CCl4. Aromatic compounds also give. This will not give. Okay. So our correct answer will be C. Next, you know that high ionization energy but 0 electron affinity. Which are having 0 electron affinity? Those which do not have willingness to gain the electron. So noble gases do not have any will of gaining or donating the electrons. Okay, so that's why they have high ionization energy, but they have 0 electron affinity. Ionization energy means what? Energy required to remove the electron from them. So they do not participate in any kind of reaction. That's why they do not give. And that's why in order to take its electron, we have to supply very, very high amount of energy. Okay. Which of the following has been arranged in order of decreasing dipole moment? So in case of dipole moment, two factors are very important. One is electronegativity and another one is the size. Okay. So dipole moment is directly proportional to electronegativity. Okay. But it is, you see here, chlorine, fluorine, bromine and iodine. Okay. That is what here, fluorine, bromine and iodine. What is happening? Size is increasing. As size increases, what happens? The dipole moment going to decrease. It is inversely related to size. Okay. But here what is happening is fluorine is having very small size. What happens here is fluorine's dipole moment overweights the dipole moment of fluorine. And that's why our order will be like this way. First Cl, then fluorine, then bromine, then iodine. Okay, even though fluorine is having more electronegativity, now the size of fluorine is very, very small. And the dipole moment of chlorine overweights the dipole moment of fluorine. And that's why our our order will be arranged in this way. Next, setting of cement in water is a process of oxidation, decomposition, reduction, and hydration. Yes, it is what? The process of hydration. Next. Methanoic acid is heated with concentrated H2SO4 to form methanoic acid. What is the structure? Methanoic acid is heated with concentrated H2SO4 to form 70. So here methanoic acid structure nikalo. Okay. HCOOH heated with H2SO4, you will get CO. Next, which of the following anion is present in single chain structure of silicates? Yes, single structure. This is the answer. KMnO4, we have solved this problem last paper also. KMnO4 acts as an oxidizing agent in alkaline medium. When alkaline KMnO4 is treated, iodide ion is oxidized to I minus, gets oxidized to IO3 minus. Okay, next. When KMnO4 is added to oxalic acid solution, the decolorization is slow in beginning but become instantaneous after some time. Because here, what is the correct answer? Because it starts to act as a catalyst. Mn plus 2 starts to act as a catalyst, and that's why the reaction becomes faster. Ferromagnetic material is. So, ferromagnetic material here is which one? GD. Okay. Next, which of the following carbonyls will have strongest CO bond? So, strongest CO bond, when we talk about the metal carbonyls. So, all these are metal carbonyls present. But here you can see that here metal and CO bond is there. Here metal and CO bond is there. Here metal is having some charge and it is there. Okay. So strongest CO bond where it will be present. When the radius will be shorter between these, then and then only it will be the strongest. Okay. So these are the metals, but this is what our metal ion. So it will have the smallest size as compared to all these metals because it is having a charge. And that's why this will be what? The strongest CO bond, because the distance between the metal and the carbon oxygen will be what? Smallest. Right? Next. Solvay process cannot be used to prepare. This is the answer, KHCO3. Next. What is the IUPAC name of this? So you know the formula for this molecule, COOH, and this is COOH, that is succinic acid. It is common name, and its IUPAC name is butanoic acid, butane 1,4-dioic acid. So here what is happening? H2O is going and we are getting the anhydride. So that's why its name will be butane dioic anhydride. So A will be the correct answer. Next, the standard heat of combustion of solid boron is equal to. So here we have to do the calculation. Okay. So heat of combustion of solid boron is equal to. We need to find out the heat of combustion for solid boron. Okay, which will be equal to delta heat of formation of B2O3, delta heat of formation of B2O3, heat of formation of B2O3. So let's start to consider the chemical equation for formation of B2O3. Formation of B2O3. So when we talk about the formation of B2O3 from boron and oxygen, B2O3. So let's try to balance this reaction. 2B and here 3/2 oxygen. Okay, Here the delta H of formation for B2O3. This is the reaction for delta H of formation of B2O3. So the balanced equation for this combustion of 1 mole of boron will be how much? So we have, this is the formation of B2O3. But in the problem, we have asked for boron only, solid boron. Here पे 2 borons है. So what I will do, I will divide this equation by 2. And I will get 3 by 4 O2. We will get 1/2 B2O3. So what I get, this is what the combustion for boron. So this combustion is equal to 1/2 of delta H of formation of B2O3. So our correct answer will be option C. Yes, next question. This is very, very important question, okay? So H2 plus I2 gives twice HI. The rate of formation of HI is this much. It is given in gram per liter per second. Then the rate of disappearance of H2 is in the form of 10x. So here we need to calculate the rate of disappearance. So you know the rate of reaction. Okay, I will write here rate of reaction is equal to minus of dH2 by dt is equal to 1/2 here dHI by dt. The reaction is like this way. H2 gives H2 plus I2 gives HI. So I will write the reaction like this way. You can write here reaction also H2 plus I2 gives 2 times of HI. So यहाँ पे मैंने वो number of moles नीचे लिख दिए. So you know that our moles per liter per second. Our unit for rate is always mole per liter per second. Unit for mole is always moles per liter per second. But right now here, it is given in gram per liter per second. See, it is given in gram per liter per second. So we need to convert that weight. We need to convert that rate of reaction into moles. So for that, which rate we have given, HI का rate हमको दिया हुआ है. HI का rate हमको दिया हुआ है. ठीक है, कितना दिया है? 25.6. So 25.6, that is in gram. So divided by its molecular weight, that is 127, which is given. You will get the answer or rate in moles per liter per second. Now you got the mole wala answer. Okay. And we need to calculate the answer in gram per liter only. Okay. See here. Gram per liter, gram per liter, gram per liter, and gram per liter. So again, we need to convert that. Okay. So ये 0.2 mole wala हम लोग use करेंगे. So for DH2 is equal to 1/2 DH by dt. What you will get? Put this value here, 1/2 into 0.2. What will be the answer? It is 0.1. Okay. Moles per liter per liter per second. This is for H2, but this is in terms of moles. So we have to convert it into gram. So for H2, right? So H2, what is the molecular weight? It is 2. So that's why it is equal to 0.2 gram per liter per second. So our answer will be 2 gram per liter per second. Okay? क्योंकि 10 raised to x में लिखना है ना, इसलिए 2. 10 into okay x. Any doubt? Next, 1 liter of 1 molar copper sulfate solution is electrolyzed after passing 2F charge. The molality of CaSO4 is here. So what is happening? So when you consider here this reaction na, 1 molar CuSO4. So CuSO4 क्या हो रहा है यहाँ पे? Cu का कन्वर्जन हो रहा है हमारे Cu2 plus 2 electron. Okay. So for that 2 Faraday of energy, 2 Faraday of electricity is already used. So how much Cu is getting converted into Cu2 plus? Okay. I will write the reaction only. So all the Cu has been already converted by using the 2 Faraday of energy. So remaining is what? 0. Remaining is what? 0. So the remaining divided by the volume, you will get the molarity. But remaining amount of copper sulfate in the solution is what? 0. It is not there because it is completely electrolyzed. Okay. And that's why molarity will become 0. Okay. Next, glucose. So glucose when reacts, glucose structure, you know, C double bond O, here it will be H. Next, here there will be OH. Next, here H. There will be OH. OH. And here 1, 2, 3, 4, 5. H, OH, OH. OH, H, OH, OH, and CH2OH. So this CO reacts with NH2OH. So here NOH and here H2. So this H2O goes And what happens is there is a formation of double bond NOH here. And this is D plus glucose. So what is the correct answer? A, B, C, D. You can see here when you match this reaction, we'll get answer. Okay. OHH, OHOH, OHH, OHOH. Next. Reagent. Okay. यहाँ पे क्या हो रहा है? ये भी reduced हो गया carbonyl compound और ये भी reduced हो गया. So what is the compound which can reduce what it is named? Ketonic group as well as acetyl group, acetyl chloride group. So LiLH4 can do both. NaBH4 also can do both. H2PD also can do both. So correct answer is all. Okay. Next. Okay, here what will be the answer? Sodium, what it will do? Sodium will form here O minus. Okay. And it will form here. OH will go here. Okay. And that's why A plus B, we will get two products here. Okay, I will write that. Here we get this answer A. Okay. I will just write the equation. Okay. Wait a minute. Yeah, let's write down that. CH3, CH2, CH, CH3, CH and OH. Sorry, CH3. Okay. So here sodium, what it will do? It will form a molecule. Okay. Like this way. And that will combine with HBr. And we will get the answer A. Okay. So time, any doubt in this? Then only I will discuss this question. If you have any doubt, then. Otherwise, some questions are remaining now. Next question. Which of the following is most stable cation? So here, positive charge is away from oxygen. Here again, positive charge is away from oxygen. Here, positive charge is near to the oxygen. And here, there is no oxygen. Okay. So here, there is a complete octet present in the given molecule. That's why this cation will be stable. Now, violation of Hund's rule is possible when the magnetic nature of B2 and OT. So, we need to consider here MOT, that is molecular orbital theory. For B2, the electronic configuration is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Right? Next is what? Pi 2px, pi 2py, and sigma 2pz. Okay, boron, how many electrons? 5, 5, 10. So 2, 2, 2, 2. Okay, it is saying that Hund's rule is possible. Violation of Hund's rule is there. Okay, violation of Hund's rule means what? We can pair two electrons at the same time in one orbital. So 2, 2. How many? 8, and here will be 2. Okay, now calculate the according to MOT respectively. Okay, now calculate the bond order. So here it will get cancel out. So here what will be the bond order? Yes. Yes, here the bond order will be, sorry, the magnetism will be diamagnetic. Boron के लिए diamagnetic हो जाएगा क्योंकि all electrons are paired, right? Yes, any doubt? Boron 10 electron, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 2 electrons. So all the electrons are paired, so that's why this is diamagnetic. Very good. Next, carbon for oxygen, what will be the nature? Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Then what is sigma 2pz, then pi 2px and pi 2py. Okay. So for oxygen, how many electron? 8 and 8, 16. So 2, 4, 6, 8, 9, 10, 11, 12, 13, 14. Right. Next, 15 and 16. Right. This is star. So they will cancel each other. There are 6, 6 minus 2. Okay. So again, this is a paired electron, paired electron, paired electron, paired electron. We need to find out the magnetic moment. We don't need to find out the bond order. So both are diamagnetic in nature. You can see all are paired. Nothing is what we can say unpaired electron. Okay. Next, a compound which can be used in space vehicle. Okay, here the answer is Na2O2. Next, complex with paramagnetic with 2 unpaired electrons. So यहाँ पे हमको क्या करना है? देखो molecule लिखना है वो जो भी है K3 FeCN6. So here positive ligand is this much. So the complex will have CN6. This is 3 plus charge positive. So here it will have 3 minus charge. Okay. Now iron, you have to find out the oxidation state for iron. So it will be plus 3. Iron is what? 26. Okay. For this one, what will be that? For iron, electronic configuration is 3d6, 4s2. But for 3 plus, 2 electron will go and 1 electron from this. So we will have 3d5. And now you can see there are how many electrons? Unpaired. 5 electrons are unpaired. 1, 2, 3, 4, 5. Okay, 5 electrons are unpaired. What we have asked? 2 unpaired electron हमको पूछा है. This is paramagnetic, but 5 unpaired electron. Next problem, this one. तो यहाँ पे आ जाएगा NiCl4 2 minus. So for nickel, it is D8, 3D8, 4s2. So 2 electron will go. D8 electron we need to fill. 1, 2, 3, 4, 5, 6, 7, and 8. So this is paramagnetic with 2 unpaired electrons. Our correct answer will be B. You can try for other 2 also. Okay. And if you need any help, you can ask me. Okay. Next, consider the following sequence of reactions. This is very, very important reaction. Okay. So let's, I will just go on that. हमको पता है कि A क्या है? Sulfuric acid है. That is H2SO4. This is H2SO4. Okay. And we need to find out D has maximum oxidation state of sulfur. E and F have peroxy linkage and hydrolysis of E produces H2O2. So all B, C and D are correct, but C is not correct, and that is what we need to find out. So here when you will write na H2SO4, ठीक है, यहाँ पे क्या है? A है ये, इस पे क्या लिखा हुआ है? प्लस इसमें H2SO4 कर दो, प्लस उसमें H2SO4 करोगे आपको क्या मिलेगा? H4S2O8. लेकिन उसमें से माइनस करना है H2O को. अगर उसमें से H2 को माइनस करोगे तो क्या मिलेगा? H2S2O7. दैट इज B. ओके, उसमें आप प्लस O करो, आपको क्या मिलेगा? H2S2O8. उसमें से आप माइनस O करो, आपको मिलेगा H2S2O6. हियर H2SO4 से माइनस करना है H2O, यू विल गेट SO3. यहाँ पे प्लस O करना है, यू विल गेट H2SO5. ओके, दिस इज द रिएक्शन. या A, B, C, this is F, and this is E, and this is D. Okay, so D has maximum oxidation state of sulfur. D में oxidation state कितना आएगा सल्फर का? 2 minus 2 into 3 minus 6, so S will have plus 6 oxidation state. Okay, when you calculate others na, you can find out that. And this molecule, which molecules? When you talk about F and see here in F, H2S2O8. H2S2O8 का structure देखो ऐसा है, H2S2O8. Its structure is like this way: HO, S, S, then OH, double bond O, double bond O, double bond O, and double bond O. So this is our H2S2O8. Okay, so what is given? E and F में peroxy linkage होगी, ठीक है? H2, sorry, this is H2S2O6. 1, 2, 3, 4, 5, 6. H2S2O8 निकालेंगे, peroxy linkage दिखाना है ना हमको. So दिखाना है मतलब होती है उसमें, इसलिए दिखाना है. O, OH, O, O, okay? S, double bond O, double bond O, and OH. See? This is the F molecule and it contains peroxy linkage. Very good. Next, E molecule also contain peroxy linkage का है. यहाँ पे E molecule है हमारा H, S double bond O, यहाँ पे O, O, H and double bond O. 1, 2, 3, 4 and here OH. So this is again contain peroxy linkage. So this is correct. This is correct. And E produces H2O2. So यहाँ पे अगर इसका हम लोग हाइड्रोलिसिस कर देंगे ना, तो यहाँ पे हम लोगों को H2O2 मिलता है. ठीक है, this is also correct. So C is not Carros acid. Yeah, C. This is not Carros acid. Carros acid is this one. H2SO5 is a Carros acid. Okay? Okay, guys? Any doubt? Next, last question. Which of the following will give us the Kurdi white precipitate with AgNO3 solution? अभी Kurdi white precipitate देने के बाद जो भी Kurdi white precipitate देगा मतलब AgNO3 will react with the chloride to give us AgCl. Okay, to give us the AgCl, whatever the Cl is present. अगर Cl हमको दिया जा रहा है तो जो भी काउंटर आयन होगा, यहाँ पे पॉजिटिव चार्ज आएगा, यहाँ पे पॉजिटिव चार्ज आएगा, यहाँ पे पॉजिटिव चार्ज आएगा और यहाँ पे पॉजिटिव चार्ज आएगा। वो जो स्पेसिस फॉर्म हो रही है, द स्पेसिस दैट विल बी स्टेबल ना, दैट विल गिव अस द कार्डियोइड पीपीटी। तो यहाँ पे देखो डबल बॉन्ड के ऊपर पॉजिटिव चार्ज आ रहा है, दिस स्ट्रक्चर इज नॉट स्टेबल। हियर हमारी बेंजीन रिंग पे पॉजिटिव चार्ज आ रहा है, इसकी एरोमेटिसिटी लॉस्ट हो जाएगी, ये भी नहीं चलेगा। यहाँ पे भी डबल बॉन्ड पे पॉजिटिव चार्ज आ रहा है, दैट इज ऑल्सो नॉट स्टेबल। बट हियर यू कैन सी दिस इज द ट्रोपिलियम आयन, right? And that's why this is aromatic. It becomes aromatic when positive charge is present there, and it is stable, and that's why this is our correct answer. This molecule will give us the cardiamide precipitate of AgNO3. Okay, any doubt? Yes, all questions are I have solved today, around all questions. Okay, if you have any doubt you can ask. कौन सा प्रॉब्लम समझ में नहीं आया होगा या समझ में आया है, यू कैन रिपीट दैट। यस, ओके। So thank you for joining in. Hope you have solved more and more problems. And if you have any doubt, you can ask here. Okay. So how was your question solving session today? Yeah. Okay. Thank you. Thank you. Yes. Okay.